Leticia H is wondering, how many zeros can the polynomial 2x squared minus 3x plus 4 have? So Leticia, a couple of answers. First, what I want to give you is the sense that the fundamental theorem of algebra says that whatever the highest degree is, that is how many roots you will have, no matter what, period. But what if you want a little bit more information than that? You can say, oh, well, it must be 2 because the highest degree is 2. But how do I know? And can I get any more information out of this just already having the polynomial right in front of us? Absolutely. So let's take a look for a second. Share my screen so that you can see what I'm seeing, because my graphics tablet actually doesn't work with the Wyzant platform. All right, here we go. So let's write the polynomial as we would actually see it in a textbook. So if we have 2x squared minus 3x plus 4, this is the highest degree, right? This is degree 1. We could think of this as degree 0. What we care about is this. This means there must be 2 roots, even if you get something along the lines, not for this one, but let's say you come down to x minus 1 squared when you factor, and so x equals 1. Well, the truth is that this is called a multiplicity. So don't be fooled. Even if you get, this is completely separate from this problem, but multiplicity, can't spell. What this means is it's 1 twice. So you still have 2 roots, even if it doesn't seem so. But how do we know more about what kind of roots? Because that's also obviously very important. And I've got 2 quick tricks to show you. So first, I'm going to make a little chart here. I want to know how many positive roots there are, how many negative roots there are, and then I want to consider the possibility that I have imaginary roots as well. Now here's the deal. Imaginary roots always come in pairs. So if I find that I have even the possibility of 1 imaginary root, I must have more than that as well. So let's find exactly what kind of roots we have. Now when I say positive, I mean if I graphed this thing, wherever this thing lies, if both roots ended up over here for some reason, they'd be positive. Or if one of them ended up over here, one is negative, one is positive, and I think you get the gist. So that's what we're looking at here. How many of each type of root or sign of root do we get if it crosses the x-axis at all? Here's what we get. What we can do is say, well, here's f of x. When x is positive, I'm just going to figure out how many times the sign switches between my coefficients. This is called Descartes' rule of signs. Well, it switches from positive to negative once here, and from negative to positive once here. Well, that's all of 2 times. So for positive x, let me emphasize, it's positive, it's possible that there are 2 positive roots or no positive roots. We go down by 2s for reasons that I hope are obvious. If we have only 1 positive root and 1 negative root, then we wouldn't get 1 and 1 for the sign switching. But we have to go down by 2s, and you'll see more of that in a second. But what if it was negative? What if they're both negative? That's a possibility. How do we test for that? Let's do f of negative x equals 2 negative x squared minus 3 negative x plus 4. Let's just see what happens. Well, if f of negative x is such, then that's going to become x. This is squared, so it's just the same as 2x squared. This becomes negative, negative makes a positive, so 3x plus 4. Notice this. This is positive, this is positive, this is positive. We get no changes in sign. No changes. So Descartes' rule of signs would say we have definitely 0 negatives. So what's the only other possibility? Well, here's what's left over. When it comes to I, if we have 2 positive roots, we've found all 2 roots. But if we have 2 imaginary roots, which could be the case, and it turns out it is, then we would have no other types of roots. Imaginary roots always come in pairs, must be recognized as such. How can we know if they're imaginary roots, not imaginative, imaginary roots, or if they're positive? This easy. Let's just use the discriminant. The discriminant is that part of the quadratic formula, negative b plus or minus b squared, square root of b squared minus 4ac. Let's get all of that under the radical. divided by 2a. We don't need all of this though. The only part we really need is this. What we can do is we can take this part, because keep in mind, if this is the square root of a negative number, then that means that our result is going to be imaginary no matter what these other numbers are that I plug in. So if I can figure out what b squared minus 4ac is, I'm good to know if I'm going to get real roots or imaginary roots. That's all I need. I may not know what the roots are, but I'll know if they're imaginary or not. So let's take that. Let's do it. That's b squared is going to be negative 3 squared minus 4a is 2 and c is 4. Both are positive. Great. So this is going to be 9 minus 4 times 2 is 8. 8 times 4 is 32. It doesn't really matter at this point what the answer is. I know it's negative. Therefore, this is the obvious case. There are 2 imaginary roots and no other. So don't stop where you are. Try and figure out don't just stop with how many roots does it have based on the degree. Figure out what kind of roots they are. It's a lot more interesting and you will impress your teacher if nothing else. All right, hope that you enjoyed this video and let me know if I can help you in any other way.